Alright, so I think the stream is working now, and we'll see if some people join. But regardless of that, today I'm going to be solving some challenges on Codewars. I'm just going to be picking out some random challenges. I'm going to go for some of the easy ones today, and we're just going to go ahead and solve some of them, talk through how to do it, and all that good stuff. So the website that I'm going to be using is called Codewars. It's a great website that you can go on and you can get some coding practice. They have a lot of different languages. They have a lot of problems ranging from very easy to very difficult. And it's a great resource to sort of get better at your programming. So today I'm going to be using Python, and we're going to look at some simple problems, talk through them. I might even try to solve some of them in one line or one statement to be more accurate. But yeah, I think it would be fun. We have a couple people watching now, so that's cool. So why don't we just go ahead and get started. The first one that I want to look at is called Fix String Case. I was just briefly looking through some of these problems, and they look kind of interesting. Or this problem looked kind of interesting. So I'm not sure how well you can read everything, but it basically says you'll be given a string that has a mix of uppercase and lowercase letters, and your task is to convert that string to either lowercase only or uppercase only. And the basic idea is that you want to make as few changes as possible. So if there are more lowercase letters, you want the whole string to be lowercase. If there are more uppercase letters, you want the whole string to be uppercase. And then it says if there's a tie, if it's an equal number of uppercase and lowercase letters, then you would convert the string to lowercase, essentially. And okay, so let's go ahead and give this one a try. So again, we're going to do this in Python version 3.4.3, so that's great. We have this solve function that takes a string, and we just need to return the string in either uppercase or lowercase based on those rules. And let's see, someone's saying the stream's not in HD. I think I set everything up correctly. It might just be my computer itself that's doing that, to be honest. I am not sure. It's supposed to be in 1080p. It looks like it might be outputting in something less than HD, but I will have to deal with that later. So let's make an attempt to solve this, and I'll actually zoom in on my solution here. Okay, so basically what I'm thinking is we have this string, we have a bunch of characters in it, and we want to look at each character and determine if it's uppercase or lowercase, and we want to sum up all of the uppercase and lowercase letters and figure out how many of each there are. So let's try, first of all, let's try just going through each letter with a for loop and summing them all up. And there are other ways that we can do this, and we can look at some other ways, but let's just start with a very simple method. So we're going to have lower and upper, and we're going to make them both 0 to begin with. And then we're going to loop through for character in S. And so this for loop is going to loop through each individual character in the string. And so, if the string is the word hello, for example, then C will first be capital H, then it'll be lowercase e, then L, then L, then O. So it's not like a for loop with numbers. It's not like int I equals 0, I is less than 10, I plus plus, none of that. It's just each individual character in the string, which should make some sense. And so then we are going to actually have to check to see if it's uppercase or lowercase. And there's a couple of different ways that we could do this. And so one way that you could do it if you want is you could say if C dot, and I'm going to pull up the Python docs over here just because I want to remember the exact, we want str. There it is. And we want to know, I think it's just dot lower and dot upper. So it should be right around, oh, so we can use these is upper and is lower. So I guess that's actually an even better way. So if the string, this character is an uppercase character, then we would do upper plus equals 1. There's no plus plus in Python. And then otherwise we can just do lower plus equals 1. And so after this for loop, we should basically know the number of uppercase letters and the number of lowercase letters, and then it should be simple to deal with. And so we can say if lower is greater than upper, then we want to return s dot, I think it's lower, just like that, but I guess I didn't actually check. It is lower, okay. And then we're going to say elif upper is greater than lower. If there are more uppercase letters, we want to return upper, and else we just want to return lower by default. And so we'll actually clean that up a little bit. But just to review, and I think this will work, but we'll just double check. So if you just joined in a little bit late, basically what we're doing is we're getting a string. So we're getting something that looks like this. And basically, if the string has more lowercase letters than uppercase letters, we want to convert it to lowercase. If the string has more uppercase than lowercase, we want to convert it to uppercase. And if it is equal, if it is the same of each, we want to just default to lowercase, like that. So it's a pretty straightforward problem. And basically the first solution, and we're going to look at a couple of solutions, but the first solution that I came up with was we're just going to loop through each character, and if it's an uppercase character, we're going to increment this upper counter, and if it's a lowercase character, we increment lower, and then here we can just return, lower or upper. We can convert the entire string based on that. And let's actually see, I think I might have messed this up a little bit. These buttons are a little bit hidden, but I'm going to... Yeah, these buttons kind of got messed up here. But if I zoom in, let's just attempt this problem. All right, great. So this worked. This solution worked. So they have 4 basic tests like these, so it's super straightforward. But then they have 101 random tests, and it passed all 101 of those. And so the idea is that if this works with a bunch of random strings, then chances are the algorithm is correct. And so this was our first attempt. It's 19 lines of code, including all of the blank lines, but that's totally fine. So we can actually make it a little bit better. And there are some fundamentally different ways that we can solve this, but let's just clean this solution up a little bit. So the first thing we can do is we have a little bit of repeated code. We're returning s.lower in 2 different cases, and it would probably be better to just do that in one. So we're going to get rid of that code there in a second. But basically, if upper is greater than lower, then we would want to return upper. But in any other case, if lower is greater than upper, or if lower is equal to upper, then we just want to return s.lower. And so we can get rid of that right there, and the code is now 16 lines, or I'll put that extra line because Python likes it. But the basic idea is we clean this up a little bit, so instead of an if, elif, and else, we just have an if and an else, which is a little bit nicer. And yeah, just to answer the question, the language that I'm using right now is Python. The plan is to just use Python for the duration of this stream and just take a look at a couple of different problems on Codewars. And so that works. That's cool. What we can do, we can start looking, and this is a really straightforward solution. If you read through this code, I think it's pretty obvious as to what exactly it's doing. It's just counting the number of upper and lowercase letters and then returning them. But we can look at a couple of ways that you might solve it that are a little bit less straightforward, maybe just a little bit different. And so when I first saw this challenge, the first thing that I thought of had to do with the ordinality of characters, and basically what that means is that each character in Python has a number assigned to it. And so what we can do, if I want to open up my terminal here, so here's my terminal. I can make it bigger like that, and if I go into the Python REPL, redevel print loop, now we want Python 3. Okay, so here's Python 3, Python 3.7. What we can do is we have a couple of functions. We have CHR and ORD. And so what I can do is if I do the ORD of capital A, like that, it will give me the number associated with that capital A, which is 65. And then it goes the other way. If I do CHR of 65, it will give me the character capital A that's associated with that number. And so basically what I can do is I can look at the ORD of capital A is 65, and the ORD of a capital Z is 90. And so any number between 65 and 90 would be an uppercase letter. And then I can also look here and I can see that the ORD for a lowercase a is 97, and the ORD, the ordinal for the lowercase z is 122. So anything between 97 and 122 would be a lowercase letter. And so Python has this really nice isUpper function. They also have an isLower function. But let's say that you didn't know that that exists, because I actually forgot that that existed. We can actually use this ordinality property of characters to deal with it. The other thing that you could do that I was thinking of is that you could do if c.upper is equal to c. So basically, if changing the character to uppercase doesn't change anything, then you know it's uppercase. If that makes sense. So basically, if C is a capital A, and I want the uppercase version of a capital A, well, it's already uppercase, so it doesn't change. It's still equal to what it was before. But if C were a lowercase a, and I call C.upper, it's going to give me a capital A, and capital A is not equal to lowercase a, so that's how you know it's different. And so if you didn't have the isUpper function, then you could do something like that. But let's actually do something that uses the ordinality property. And just to answer the question really quick, so Codewars is a challenge where you can, it's a website where you can solve different coding challenges. You can basically make an account on here, and you pick a bunch of different languages, a bunch of different challenges. You can choose a bunch of languages and different difficulties. So this is a really easy problem. Basically 8 is the easiest, and then it goes all the way down to 1. And then every challenge you complete, you get some points. So these are my points right up here. I'm a level 3, which is pretty decent, but I haven't actually touched Codewars in quite a while. But it's a fun site. And so let's actually get back to this. Let's do some ordinality stuff. And so basically, if we want to check to see if the number is uppercase, if the character is uppercase, we want to see if its corresponding number is between the numbers for a capital A and a capital Z, which is 65 and 90. And so what we can do is we can say if 65 is less than or equal to the ordinal of that character, which is also less than or equal to 90. So basically, we take the ordinal of that character. So for example, let's say that it's a capital, I don't know, S. And we take a look at that, and a capital S corresponds to the number 83. So is 83 between 65 and 90? Well, yes, of course it is. And so therefore, we know that the capital S is in fact a capital letter. So if the ordinal of our character is between 65 and 90, we know that it is an uppercase letter. If it is between whatever we saw before, if it's between 97 and 122, we know it's a lowercase letter. If it's not between those ranges, it's some other symbol. And so let's give this a try really quick. It passes the 4 basic tests, and it's going to pass all 101 random tests as well, so that's awesome. So this is just another way of doing it. If you didn't know about the isUpper function, then you could go ahead and do it like this. You can basically check to see if the ordinal value of the number corresponds there. So this was my initial thought when I read through this problem, but then I found the isUpper function, which I would say is better. But if you don't know about it, or if you're looking for another way to solve it, because there are lots of ways to solve all these problems, then there's a good solution for you right there. And so what we can actually do then is we can actually make this problem even more interesting, because what we know based on the instructions, well, as far as I'm concerned, so you're given a string that may have mixed uppercase and lowercase letters. What I'm wondering is if this string also has symbols, or if any of these strings might have symbols in them, because if they do, then this would make this other solution not quite as good. But if there are no symbols in any of the strings, then it would make things easier. But I guess we don't really know for a fact whether or not there are any symbols, and so we probably shouldn't assume that there won't be any symbols, as in there could possibly be some symbols. So let's just clean some stuff up a little bit more, and then I think we could probably move on. First thing is we don't need this else here, because if this if statement is true, it's going to return that value, so it's going to stop the execution of the function. So the only way that it will reach down to here is if this if statement is not true, and so we don't need to have the else. Now we do need to have the else here, basically because the if statement, if I got rid of the else here, then the if statement would run, but there's nothing stopping this, statement from running. But here, if this if statement works, it's going to return, it's going to actually stop the execution of the function right there, and so we don't need to have the else down there, so that's great. And then, we could do some crazy stuff. We could do some stuff with list comprehensions. Let's actually do that for a second. Let's write a list comprehension that will sum up the number of lowercase letters. And so what we could do is we could actually say that lower is equal to the length of some list comprehension. And so basically we're going to filter the string to just look at all of the lowercase letters, and then we're going to count the number of lowercase letters that we get. And so we're going to basically say C for C in S if C dot is lower, like that. And so what this is going to do, I just want to make sure this is clear, is we're going to look for each character in the string, and if that character is a lowercase character, then we're going to put it in our list. And so essentially, to look at an example, if we look at this example right here, we're going to look at this lowercase c, and we're going to say, okay, the lowercase c is a lowercase letter, so we're going to stick it in our array, in our list rather. The O is lowercase, we're going to stick it in there. The D is not, so we're going to not put it in. And then the lowercase e is lowercase, so we're going to stick it in there. And at the end, our list would have 3 elements in it. And we only care about the number of lowercase letters, so we're just checking the length. We're checking the number of lowercase letters that we get. And then I'm going to do something similar for the uppercase, and then we're going to try something. So we're going to say if C dot is upper. And this code is pretty much the exact same. I'm just saying if it's an uppercase letter instead of if it's a lowercase letter. And so what this does is it lets us get rid of the C right there. It lets us get rid, lets us get rid of this for loop. So instead of this for loop, we can basically count the number of each letter in one line. And there's different ways to do this. You could, there's a lot of ways to do this. There's probably some built-in function, something in itertools or whatever that might be even easier, but this is really straightforward. And so that lets us get rid of the for loop. We could still do this ordinality thing. Instead of calling C dot is lower, we could say, if C is between 97 and 122, so on and so forth. But basically we can get rid of this for loop. We can use the list comprehension, and now we're down to 8 lines, including 2, so it's actually 6 lines of real code. And so let's see if this works. We passed the 4 basic tests, that's great, and we passed the other tests, so that's also great. And so then that is great, this works. And now we got a comment, which is actually what I was about to do, is you said you could do upper equals the length minus lower, and that was a really good idea. This is kind of something that I was hinting at before. I basically said we're not sure if the string can have things other than uppercase and lowercase letters. Basically, if the string can only have uppercase and lowercase letters, then you could say that the number of uppercase letters is the total number of letters minus the number of lowercase letters, right? So if there's 4 letters in the word code, and 3 of them are lowercase, then the number of uppercase are the total, which is 4, minus the number of lower, which is 3, so you get 1, and that works out. The problem with this is that if there are symbols in any of the samples, then this will mess things up because a symbol is neither a lowercase letter nor an uppercase letter. And so what we can do is we can actually try, let's actually try this. We're going to say that upper is equal to the length of the string minus the number of lowercase, and let's just see what happens. It's going to pass these 4 tests because, it's just code, but let's try it with the random strings. Okay, so it does pass. So it basically says you'll be given a string that may have mixed uppercase and lowercase letters. So this problem is actually it could be worded better. It should say the string will only contain uppercase and lowercase letters. I'm assuming that was the idea. So if we assume that there's only going to be uppercase and lowercase letters, then we can make we can make this assumption, and we don't have to have 2 list comprehensions, we only need to have 1. And that makes things a lot nicer. Let's clean this up even a little bit more. We're going to use a ternary operator to get rid of this if statement here. So we can say return s.upper if upper is greater than lower, else s.lower. And then we can get rid of this if statement. So basically, this is a ternary operator. We're going to return the uppercase version if the number of uppercase letters is greater than the number of lowercase letters. Otherwise, we're going to return the we're going to just return the lowercase string. And so that's it. We're just replacing the if statement with a ternary operator. So we're now down to 4 lines of code, including the function header. So 3 lines of our own code, and it's still working, of course. So that's great. What we can actually do is we can make this one line really easily, because we don't even need these variables upper and lower anymore. We could just stick upper in there, and then we can stick lower. So this is actually where it gets interesting. I was going to say we could just stick lower in here, right? We could do that, but then we'd also have to stick it in there. So we would have to have this same piece of code in 2 places, and I really don't like that. I think that's kind of ugly. So let's get rid of upper first. The idea is that len s minus lower, we can substitute that for upper, and we can say if len s minus lower is greater than lower. And actually, you could just do some math here. You could say if you add lower to both sides, then you would basically cancel that out here, and you would get 2 times lower there. And so we can just go like that. And I think that this will work. It'll work. Great. So that is one way to do it. I was actually going to do it a much more complicated way, and that will probably come up in another challenge that we do. But here you go. This right here is a one-line solution to this problem. So it looks really confusing right here, and we got it took us a long time to get to this point. Especially this part right here, the length being greater than 2 times the number of lowercase letters. That is not, obviously apparent, I don't think. Maybe if you thought about it for long enough. And there's other ways to do it, of course. But basically, we got it down to 1 line of code. This one isn't even that long of a single line. But it's really cool when you work with Python, because there are so many ways to solve each problem. And you can get them down. You can get a lot of these easy problems down into 1 line. Sometimes they get a little bit crazy, but this line was actually not terribly crazy. And so let's go ahead and actually submit this code, and it's going to submit my final solution. And so you can see actually the top, a lot of these top solutions were pretty similar to what we did. And so like this first one, instead of using a list comprehension, they used the map function, which also works. So they summed the count of the map function, and there's that multiplied by 2 thing that we had, and there's the ternary operator. This person did something pretty similar. They basically just counted the sum of all the letters, and they put a 1, if there's a letter, and so you're just summing a bunch of 1s. And instead of checking like is lower, they check to see if it's in the string of all lowercase letters. So, not as clean, but you can see a lot of these. And then when we get down to here, this is a solution kind of like what we had before. And then this one's pretty crazy. There's a lot of crazy solutions. But the top solution up here was very similar to the one that we did. So I actually like that problem quite a bit. I'm going to say that I'm very satisfied with that. And that was awesome. To answer someone's question about the ternary operator, it makes too much sense. I agree, because the ternary operator, if you read this, it's something if there's a condition, otherwise or else it's something else. I think that the ternary operator in Python is really nice. In other languages, you have condition question mark value if it's true, colon value if it's false, in a language like Java, which is fine, but the Python version is more natural. I think you can read it out loud better, and so I like the Python version. Let's go back here. So we're at Python, we're at level 7, which is very straightforward. And so let's try unique pairs next. I glanced at this one briefly But yeah, so I glanced at fixed string case and unique pairs briefly, but we'll look at some other ones that I haven't actually taken a look at yet. And so in case someone has joined, in case people have joined, I'll just really quickly reintroduce this. So I'm on a website called Codewars. It is a website where you can do coding challenges in a variety of different languages at a variety of different skill levels. You can practice, practice your code, learn new things, practice your skills, which is really important when you're coding. You should, practice every day, at least think about it every day, so you get better. But basically, you can do these challenges, you get a rank, you get a score, you can, follow your friends and compete with them. Back in high school, I got a bunch of people into Codewars in my computer science class, and so we would all kind of compete with each other to solve hard problems or to get a higher score or whatever. So it's a cool way to practice code if you like the competition, or even if you don't, that's totally cool too. But let's go ahead and actually solve this one. This is called unique pairs. It's a level 7, which is a very easy one because 8 is the easiest and it goes down to 1, which is the hardest. So we're just doing some easy problems in Python today. And so this says Mrs. Frizzle, I think from the Magic School Bus, is beginning to plan lessons for her science class next semester. Basically, she wants to ensure that each student has a chance to partner with every other student in the class in a series of science projects. So each person should work with every other person in the class at some point. Mrs. Frizzle does not know who will be in her class, but she knows the number of students in the class, which we'll call n. And so we're going to create this function called project partners that will take the number of students in the class, and it will return the number of partners, the number of pairings. And so basically, if you have 2 people in the class, there's only one possible pairing. You take those 2 people and you pair them up. Super straightforward. If you have 4 people in the class, you can kind of imagine drawing this out, but you have the first person can partner with any of those 3 people. So the first person can go 1, 2, 1, 3, 1, 4. So that's, 3 so far. And then you can have the second person can partner with the third or the fourth person because they already partnered with the first person, so that's 2 more. And then the last 2 people, number 3 and 4, can partner, so that makes 6. And so if you have 4 people in the class, you have 6 total pairings of those people that you can do. And so that's great. And so you can think about this for a little bit. If, convince yourself that these 2 examples make sense. Make sure that you kind of get what's going on here. But when I thought of this, the first thing that I thought of was combinatorics, combinations and permutations. And especially, this sounds, a lot like a factorial. You have the first people, you have like 3 and 2 and 1 and so on. And it's not quite a factorial in that sense, but you should be thinking somewhere along the lines of combinatorics. And so we are going to actually write this function that's going to take the number of people and return the correct value. And so let's actually test my sort of idea that I have here. And so let's go ahead and I'm going to do... so if you have 4 people, for example, and you want pairing, so you want 2, so let's try 4, choose 2, and Google will tell me that value is 6, which is indeed the correct answer. If we have 5, choose 2, for example, that should give us 10, which is the answer that we have here. And so we can tell pretty much that we can just use the formula for the combinatorics for choosing a value. So it's going to be n choose 2. And I'm sure that this function is like built into Python somewhere. Let's just write it ourselves first, and then we can go and hunt for it, because there's actually a couple of interesting things that we can take a look at here. And so let's actually look up the function. I know it's like n factorial over k factorial, and there might be like an n minus k in there, but let's just look it up. Formula for n choose k. People seem to like this. So here it is. N choose k is n factorial over k factorial times n minus k factorial. So that is the value right here. And in this case, n would be, I think, the number of students, and k would be, n would be, I think, the number of students, and k would be 2, which would be that we want them to be in pairs. And so let's just write this down so we don't have to keep referring to it. I'm going to write right here. Let me zoom in on this. I'm going to write up here n choose k equals, and it's going to be n factorial over the quantity k factorial times n minus k factorial. Let's just double check that. K factorial times n minus k factorial. Fantastic. Okay, so that is the basic formula that we're going to want to work with here. And so let's go ahead and first let's write a factorial function. And we're going to write a recursive function, and we're going to do it in a naive way. We're just going to basically brute force it. And we'll come back to it, but let's just write this for now. So we're going to write a factorial function. Let's just call this parameter x to avoid confusion. But factorial of x is going to return x factorial. So if x is 1, or if x equals 1, we just want to return 1. But otherwise, we want to return x times the factorial of x minus 1. And I think everyone watching this probably knows how factorials work, but just really quick, 4 factorial is equal to 4 times 3 times 2 times 1, which is the same thing as 4 times 3 factorial, right? Because 3 factorial is 3 times 2 times 1, which is that. So 4 factorial is 4 times 3 factorial. That's what we're doing. We're saying that x factorial is x times x minus 1 factorial, but eventually we are going to have to stop somewhere, and so when we get down to x being equal to 1, we're going to return 1. You know, you could actually, I guess, stop this at 2. You could say if x is 2, return 2, but let's just leave it like that. And so when we get x down to 1, we're going to return 1, but otherwise we're going to return the factorial of x minus 1. And just take my word for it that this works. We'll come to see that it works, but it's going to take a little while for us to get there. But I don't think that I made any mistake there. Feel free to point it out if I did. But let's go ahead and do this, because all we really need to do is just return this formula right here. So all we have to do is we need to return the factorial of n divided by the quantity factorial k times factorial of n minus k, like that. And I'm saying k, but k should actually be 2. We can just hard code that in. And once again, it's 2 because we want to make pairs. We want partners. If you wanted groups of 3, you would just put 3 there, but we just want pairs, so we're putting a 2 there. So there's our initial stab. Let's run the samples, and we get an error. We are getting some recursion errors. And I think, well, let's see. So it's doing the factorial. Okay, right. So the problem is that the first time this happens, n is 2. And so we're doing, n minus 2 factorial is 0 factorial. And we didn't actually handle for that. So let's just handle for 0 factorial, make that simple. And the interesting thing is that 0 factorial is defined to be 1. It doesn't necessarily make sense, but it's true. So 0 factorial is defined to be 1. And so what we could do is we could just say if x is 0 or x is 1, you could write that a different way. We're not going to worry about negative numbers because that's just not part of this. You could simplify this if you want. But if x is 0 or x is 1, we just want to return 1. And so that will deal with that issue. Now we passed these tests, but I have a feeling that we're going to fail these. And so basically what happened is I believe we ran into a recursion issue. I think, yeah, so there we go. This is what I was looking for. So the maximum recursion depth was exceeded in the comparison. So basically what happened is the number that they passed us was way too big for us to be able to handle, and so the program it crashed. And so this works for these small numbers, 2, 3, 4, 5, but it's not going to work for big numbers because we're basically just brute forcing the solution right now, and that is not great. And so let's actually go ahead and solve this a better way. Now this says that the solution should not contain any arrays or objects that are used similar to an array. We're not going to use an array. We're going to use a dictionary, which is like a hash map in Java, and I don't think that that's against their rules, and in fact I don't think you can solve this without that. And we're going to apply a technique that's called memoization. And I don't know if I've ever made a video on this. I definitely will if I haven't. But basically the idea is that this factorial function is doing a lot of repeated work. So for example, I find 4 factorial, and then later on I want to find 5 factorial. Well, that's just 5 times 4 factorial, right? So if I already calculated what 4 factorial is, I shouldn't have to calculate it again. If I already know what it is, and I just multiply that number by 5, super easy, right? But if I need to recalculate all of 4 factorial again, that's going to take up a lot of time, or really it's going to go very deep into the recursion, and we're going to end up with an error like that. And so what we can do is we can use memoization. We're basically going to cache all of our results. So every time we get a result, every time we get a factorial, we are going to store the value of that so that we can just reuse it if we have it already. And so what we can do is we can say, we can call this, I'm just going to call it memo, and we're going to make it an empty dictionary. And I'm putting this outside of the function because if I put it inside of the function, it would get cleared every time the function is called, and it would therefore be useless. And so what we're actually going to do is we're going to change this to say the answer is equal to this, and we're going to say memo at index x is equal to and. So basically, we're going to say the key is the number whose factorial which we're trying to find, and the value is this sort of solution that we've computed here, and then we're going to return it. So all I'm doing is, instead of just returning the answer outright, I'm also storing that answer in this dictionary right here. And then to actually use it, we can say, elif x in memo. So if x is stored in our memoization dictionary, we just want to return memo at index x. So what will happen is, if we've already calculated x factorial, we can just return the value that we have saved instead of having to recalculate it, which should help out. And so let's see if this works. So that passes those 4 initial tests, but we didn't have any trouble with that before, and we were unable to solve it this time. I can't tell you if we got any farther. I guess it says it passed 10 assertions and then it failed. I'm assuming there are more than 10. It says 10 out of 10. I'm assuming there are other assertions that we are failing. But essentially the idea is that we were not able to sort of solve this in enough time, even with the memoization. I think the issue is really, I think the number is probably just really big, and we're calculating factorial 3 times here. I wonder if we could actually print n and see what it is. I don't know if that will mess things up. Okay, so let's just see. Let's see if it'll tell us. Okay, so it's failing here. I'm assuming this means, okay, so here's our test. It's 4,101. And so we're trying to find 4,101 factorial, and that is obviously a lot. So I had that memoization trick up my sleeve, but if that's not enough to help, we'll have to look elsewhere. Before we actually try and fix our code, I'll show you one trick that you probably shouldn't use, but that might be kind of helpful. And so what you can do, I need to look up exactly what it is, but you can actually change, because this error basically says that we have the maximum recursion depth exceeded. You can actually increase the recursion depth to be even bigger. And it's some function in sys, so I just need to look for it. So it's like Python sys set max set recursion something or other. Let's just see if we can find it. This should tell us how to increase it. So sys.setRecursion limit, and it's going to say this is a bad idea, but let's just see what happens. Import sys. Sometimes if I get really frustrated, or if I at least want to know that my code works, then I will try this, maybe just temporarily. But let's set the recursion depth. We set the limit to be the number of frames that we want. Let's set it to 5,000. I don't know what the default is, actually, but it's not going to tell us, so that's fine. Let's just see. Okay, so that actually fixed our issue. Basically, the idea is that the recursion, it was just too many, basically too many frames. It was going too deep down. So we can actually just tell Python, like, no, I actually want that to happen, and then Python will you know, basically accommodate you there. Now, if you make this too big, you could eventually run out of memory on your computer. It could freeze, it could crash, whatever. And this is not a very good idea, but just to show you that the code that we have does work, and I can tell you that the memoization does help. You know, it might not be super obvious, but it does help. And so you can see these numbers got quite big indeed. It got up to 7,296 here. I think these are just random numbers. But the point is that the numbers can get very, very big, and it can be hard to deal with it. So let's just see. You know, I think this solution is fine for now, and I know that there's a better way to do it that I'm blanking on. And I know that when I submit this, I'm going to see someone that did it a better way, and I'm going to slap my head and say, wow, I didn't think of that. But let's just see if Python has a built-in factorial function. So it looks like it does. It has math.factorial. I wonder if the math factorial function's any better. Let's just comment out all of this code. And then down here, we're going to import math, and we're just going to call, or you can actually say from math, import factorial. Then we don't have to touch this code at all. Instead of using our own factorial function, we're going to use the factorial function in the math class. And so that works. And that works. Okay, so it looks like the factorial function that's built into Python is better than the one that we have. I wanted to write it ourselves just to sort of get an idea, get an intuition as to how it's working. But obviously, since Python has it built in, you would want to use the built-in function. And so this is already, you know, a one-liner. It's just this factorial stuff. And yeah, I mean, if we had all this other stuff, it would be obviously quite a bit more. But we don't even need to have it. And so I guess I'll just delete it before we submit. But we basically made a one-liner here, which is pretty cool. Now, if you wanted this to actually be a one-liner, I'll show you a good trick in Python. This is basically a one-liner, but we have this pesky import statement, and we need to have it. So let's just say that we wanted to make this an actual one-liner. What you can do is there's this built-in function called import with 2 underscores like that, and so we can import math, and then we can say dot factorial like that. And if I run this, it's going to work just the same. And so I'll show you really quick. Let's just paste this in to all 3 places, and I'm going to get rid of that top level import. And you'll notice that it still works, right? And I can, if I get rid of this import, it's not going to work. It's going to tell me I can't find factorial. But with this import, this is basically a way to have an import as a statement. And so I can go like this. The problem is that I'm repeating it 3 times, and that's a little bit annoying. And what you can actually do is you can use this trick, and this was going to come up eventually, so I'll just bring it up now. You can use this trick called the immediately evaluated lambda function. And so basically what this means is you can create a lambda function with some variables. The basic idea is that we want to have a variable. We want to store this math import like sort of as a variable, so we can use it multiple times instead of having to call import 3 times. But if you define a variable, so if I say something like a equals 1, and then I want to print it out, you know, I could do it on 1 line, but it's 2 statements, right? There's a semicolon, and the goal is we want to do this in 1 statement. And so what we can actually do, let's go back to this example. If a equals 1 and we want to print out a, what we can do is we can create well, obviously you could just print out 1. But let's say that you wanted to print out a, and you also wanted to print out a times 2. So you want to print out 1 and then 2. So you're using this value of a twice. And let's say that a is actually something that the user is inputting. So you can't just take this and stick it in there twice, right? Because if the user, this is going to ask the user for their input once, then it's going to ask for it again, but we wanted to use the same value. And so what you can actually do is you can create a lambda expression that takes a, and it prints a and a times 2. Right, so this is a function. It's a function that takes a parameter called a, and what does it do? It prints out a and a times 2, and then what you do is you wrap it in parentheses and you call it immediately with the value that you want, like that. So these two statements here are equivalent, but this one, or these two lines are equivalent, but this one right here is two separate statements, and this one right here is one. The basic idea is that we only ask for the input one time, but we essentially bind it to this variable called a, and so this is how you can have a variable that you can reference multiple times in one statement. This is really common when I try to solve these problems in one line of code. A lot of times I'll need a variable, and so this is actually what I'll have to do. I'll have to use a lambda function like this. And what we can actually do is we can wrap our solution. We can wrap this in a, let's say, lambda fact. And we're going to do the fact of n divided by the fact of 2 times the fact of n minus 2. And I just realized that we don't actually need to call this here. We could just say that this is 2, right? Or we could call it. But the idea is that we're wrapping this, and then we need to sort of pass a value for fact, and that's just going to be import math dot factorial. Because remember, you can pass functions around in Python. They're first class members. And let's get rid of this. And so the last thing we need to do is we just need to return this. And so this is just like if you really, really want it to be on one single, oh no. Whoops. If you really, really want it to be on one single line, I can't believe we just lost all of that. Luckily, we didn't care about that other version because now I'm going to have to rewrite it. The basic idea is that if you really, really wanted everything to be on one line, then you could do, you could basically do this. But if you don't care about it being on one line, then there's no reason to do this because it's kind of ugly. Okay, so I think that's what we had before. I'm going to try and not get that code deleted again. And what did I do wrong? I have 2 parentheses there, and that should only be 1, so I might be missing one. Now I think... Okay, so this goes, and it's fact n. Let's see. I think I'm just missing a parenthesis or something. Yeah, so we have fact n over this quantity times this quantity, and then I'm missing a parenthesis right there, I think. Okay, so there we go. So once again, this is an ugly solution. You should just write from math import factorial at the top, but if you want to have it be in one line, and I like to solve these problems in one line, then that's basically how you can do it. But if you're writing real code, I would not recommend that. So let's take a look. Okay, so that is a pretty smart solution. All right. Well, let's see if anyone did it the way that we did. So here's someone that did the factorial way, so that's good. But it looks like it was actually a lot simpler than we had to do. I think this is the sum of the numbers from like 1 to n is n times n minus 1 over 2. So I guess if we thought about this a little bit more, we could have come to that solution. And that's sort of the thing about Codewars that I really like, is that at the end you get to see everyone else's solutions, and you can realize that there might have been a really cool way to do it, or a really simple way to do it, or maybe you really did come up with the best possible way. And in this case, I did not come up with the best possible way because this version doesn't have to deal with factorials or recursion. It's super, super straightforward, and so I'm going to upvote that one. But alright, so, you know, you don't get every single one perfect, but we did solve it eventually, and we explored some interesting concepts along the way, so that's cool. Let's try another one. I've been doing this for about 50 minutes, so I might call it after this one, depending on what's going on. And also, if you're watching and you have any questions or comments, you can feel free to leave them. But let's see. So this is telling us, oh, this is a good problem. So this is giving us an array of, or a list of values of 1s and 0s, and we have to convert this into the binary representation. So for example, 1, 0, 1, 1 corresponds to 11, 0, 1, 0, 1 is 5, so on and so forth. And I'll just really quickly explain this. I think I might have a video explaining this, but basically the way that you can convert these is each place is a power of 2, and you read them from right to left. So basically this place is 2 to the 0, which is 1. This is 2 squared. This is 2 to the first, which is 2. 2 squared, which is 4. And 2 cubed, which is 8, and so on and so forth. And so if you look at a number like 9, this is 2 cubed, which is 8, plus 2 to the 0, which is 1. So 8 plus 1 is 9. If you look at 15, for example, this is 8 plus 4, which is 12, plus 2, which is 14, plus 1, which is 15, and then 11 is just 8 plus 2 plus 1, which is 11, of course. And so that's basically how you convert. And the challenge is that we take this input and we get a value. And it's saying that the arrays can have varying lengths, and it's not limited to 4. So we can't just hard code sort of that solution. And so let's first try this, you know, in a simple way. Let's just loop through each value, and we're going to, you know, do the conversion. And my feeling that I'm getting is that these arrays are probably going to get pretty big, and the solution might end up not working, but, you know, we'll see what happens. Okay, so basically what we want to do is we want to loop through each index in the array, and we want to multiply that corresponding value by its corresponding power of 2. So with this 1, the corresponding power of 2 is 2 to the 0, which is 1. So we would do 1 times 1, and then we'd add to that 0 times 2 to the 1, which is 0 times 2, which is 0, and then 0 times 2 squared, which is 0 times 4, which is 0, so on and so forth. And so basically if there's a 0 there, then, you know, nothing, it's just 0, we're adding 0. If there's a 1, we're going to add the corresponding power of 2, and that's how the conversion works. And so basically, since we care about both the value and the index, we need to use a for loop with a range. And so we're going to say for I in range len arr. So we're going to loop through each value in the range of the array. So basically if there are 4 values, then I will go 0, 1, 2, 3, you know, so on and so forth. Pretty straightforward. I think a lot of the people watching know Python, or they at least have a pretty good idea of what's going on, and so that is good. So we're going to loop through each index, and we're basically going to say, so we need to have our answer right here, which will be 0 by default. And so we're going to multiply, we're going to say the answer, we're going to add to the answer the value at that index, which is either going to be a 0 or a 1, but we're going to multiply that value by its corresponding power of 2. And this is a little bit tricky because right here, this is actually index 0, but the corresponding power of 2 is 2 to the third, right? And then this is index 3, but the corresponding power of 2 is actually 2 to the 0. So what we need to do is we need to multiply this by 2 to the power of something, and that's going to be it's going to be the length of the array minus I believe. We might need a -1 in there, but let's just think about it for a second. So if there's 4 values in the array and we are at index 0, that's going to be 4 minus 0, which is 4, so I think we need that -1 in there. So the basic idea is, let's try this again. So this is index 0, so I is equal to 0 right here, but we need to get 2 to the third. So we go the length of the array, which is 4, minus I, which is 0, so we still have 4, minus 1, which is 3. Then we go to here, this is index 1, and this is 2 squared. So this is 2 to the power of 4 minus 1, which is indeed 2, so that works. And then let's just look at this last one for a second. This is index 3, and it's supposed to be 2 to the 0. So it's the length, which is 4, minus 3, minus 1, which is indeed 0. So this formula should work. So we're basically looping through, and we're adding to the answer each index multiplied by you know, its corresponding power of 2. And so at the end, we can just return the answer. If we run that, it works. Let's just see what happens. So wow, that actually passed. I guess they just are not giving us very long arrays. Or lists rather. If the list were very long, this would probably fail eventually because you're doing 2 to a power, and you know this power is going to keep growing. and eventually you'd run into an issue, but I guess that the lists they're giving us are not very long, so you know, we could actually just submit this answer right now. But we don't want to submit this answer yet, because we could actually do a few things here, and of course we want to turn this into one line eventually, but we'll get there. And so the first thing that I want to take a look at, and I haven't looked at this problem ahead of time, so I'm really just sort of thinking through it off the top of my head. I've done binary problems like this before, but I haven't looked at this problem. I just picked it out of that list. There's a function called bin, and I think so you have to pass an integer. That makes sense. So if you pass, there's this bin function that you can pass a decimal number, and it gives you the binary number. It starts with 0b, but then the rest of it is the regular old binary number. So 12 is 1100. It's just 8 plus 4 plus 0 plus 0, so that's 12. But basically there's this bin function that is kind of interesting. And we almost want the reverse of this. We want one where you can stick in a binary number and get out a decimal number. And I don't think that there's a decimal, so I wonder if we could, that's okay. I wonder if we could just look up Python opposite of bin. And again, I didn't prepare anything ahead of time, so I'm kind of just, this is what I would do if I were solving this problem. I just, search it up, go on Stack Overflow, whatever. But it says here we can actually use the int function, and we can pass the radix or the base. I don't know if it's radix or radix or whatever, but you can pass the base, which is 2. And so let's actually just see if we do int of the number, let's say 1101 in base 2, it gives 13, which is the correct answer. So that's pretty cool, actually. I wonder if we could do something with that. I'm going to go ahead and comment this out, and let's actually try and solve it like that. So basically what we want to do is we want to take this array and just make it one string, and then we want to call that int function on it. And so basically what we can do is we can say, if we want to do that, we can say an empty string dot join arr. So we want to join each value in that array to an empty, with nothing in between. So this will basically take each of these values. So if it's 1, 1, 1, 1, whatever, it's going to make it just the string 1, 1, 1, 1, 1, 1, 1, 1, which is exactly what we want. There is a minor issue, though. If I try to run this, it's going to tell us that it expected a string, not an integer. And that's because ARR is a list of integers, and the join function expects a list of strings. And so to fix this, we can just simply map each value to its corresponding string. So instead of passing ARR directly, which is a bunch of ints, we need to convert it to a bunch of strings. And so basically we take each value in ARR, we call the str function on it to convert it to a string, and that's it. You could write the same thing with a list comprehension. You could actually write, I'll show you, you could write str of c for c in ARR, or I guess you could call it probably I, because they're integers. But you're basically just converting each integer in this array to a string. And so I'll just show you, nothing's going to happen obviously, but if I run it, it's not going to give me an error. So that's the point. But basically we join this to a string, and this is now just that one string. And then all we need to do is we need to call that int function on this string in base 2. Let's see if this works. All right, awesome. So that's another way that you can do it. We basically took this array, we collapsed it into a string for that number, and then we converted it from binary to a decimal number, and this 2 here is because it's in base 2. So that's another way you can do it, and that's obviously a one-liner. That's pretty nice. You could expand this out to be like a for loop or something, but obviously we don't want to do that. We can make that a one-liner, and so that's cool. Let's just go back to this other one for a second. And I think there was something else I was going to do, but let's just convert this into a one-liner, and then we'll have two different solutions to this problem. So when you have a for loop like this and you're just adding stuff up, it's actually pretty simple to convert this into a one-liner. Basically, answer, we just have this variable answer, and we keep on adding to it. So we're going to have some sort of a sum here. And the sum is going to be, so we're going to have a list comprehension, and it's going to be basically this for I in range len ARR. I think I'm missing that. Okay. So that's it. You're basically, all you're doing is you're saying, okay, well, there's a plus equals here, so we're summing a bunch of stuff. Let's use that sum function. And then this is the actual value that we want to sum. Right, and then we have, then our condition is just our for loop. So this code looks really, really similar to this code down here, but the idea is that we can get rid of this and we can just return this result. And so if I go ahead and attempt with this code, you'll see that it works as well, of course. But basically we have two different, very different one-liners right here. We have one that uses the int function, and we have one where we actually sort of compute the powers of 2 ourselves. And I don't think there's much else to say here. One thing you maybe could do is you could add like an if. You could say if ARR at index I is not 0. I'm not sure if Python is smart enough. I think maybe if you try to multiply ARR at index I and it sees that it's 0, it will ignore this power of 2 right here. But just in case it doesn't, you could add this. If the array were bigger, if the list were bigger, you might run into issues with this power of 2 here. And so, yeah, I don't think we need that for this, but that might be something you could consider. The other thing that might be worth pointing out is if you wanted to write like a recursive power function, you could do that. Well, let's see. Would memoization help? I don't know if memoization would help, but basically you could write your own power function instead of using the built-in one. I wonder if there's a power function in here. So there is actually a math.pow. So I'd assume I'm not sure what the difference is between calling math.pow and using the two asterisk notation. But if you were running into some sort of issue, you could try it with 2 asterisks. But I want to submit this first one, this one right here, because it's just a lot shorter. So let's go ahead and submit this one, and then we can see what some other people came up with. So, okay, so the first answer is that answer that we had. It's the exact same code, except they have 2 quotes. They have double quotes instead of single quotes. I personally prefer single quotes myself, but it doesn't make a difference. So I think, this groups a bunch of people together, and since ours are the same except for single versus double, which doesn't make a difference in the code, like my answer would be grouped under here. So I'm one of these 260 people, that solve that. This person did it in a similar way by omitting well, let's see. The only thing they did was, instead of calling the map function, they just used basically a list comprehension. When you don't have the curly braces or the square brackets, you get a generator comprehension. So this statement's actually a generator instead of a list. But it ends up doing the same thing when you pass it to join, so it doesn't matter. This solution is the first solution that we did, where we're just looping through and multiplying, except they are doing, so they're doing s equals s times 2 plus digit. So they're taking this value of s, instead of adding to it, they're actually just like incrementing it by the correct amount each time. So that's actually kind of clever. Here's a one-liner that's using sum. It's a little bit more involved than that. This person is using logical operators. I actually like that one a lot. So they're using binary operators. They're using shifting and logical or. I am not 100% sure how this is working, but essentially they are calling this reduce function. So they're taking, for each value in an array, they're keeping some variable n. So n is like their so far variable, and b is the one that they're looking at right now, and they're just basically doing n left shifted by 1, and they're ORing it with b. And I would have to sit down and think about this a little bit, but basically this, I guess, ends up giving the correct answer. And I think I think we've gotten a pretty good idea of how different people have gone about doing it, but our solution was pretty much the equivalent of the top solution. I guess like this is the one that we did. It just has single quotes instead, but it got grouped there. So that's pretty cool. I like this one a lot. And let's go back. Still some people watching. I think maybe we'll go ahead and try one more, because I've been doing this for a little over an hour. Let's try... I want to look at remove duplicate words, because if this is what I think it is, it might be actually a pretty interesting one. Okay, your task is to remove all duplicate words from a string, leaving only single word entries. Okay, this one's going to be really easy, actually, hopefully. Okay, so it looks like we need to keep everything in order, which might be a little bit tricky for how we're going to solve this, but basically the idea is that you have this string that has a bunch of duplicate words in it, and you only want to get one, instance of each word. So alpha, beta, beta, gamma, gamma, blah, 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 so on and so forth. We just want alpha, beta, gamma, delta. Every other word there is a repeat of another word, and we don't want that to be there. And so this is the perfect problem, hopefully, for a set. And I don't know if I've done a video explaining sets and how they're used. I feel like I did, but I'll have to check after this. But the basic idea is that a set is an unordered collection of values in which you cannot have duplicates. And that's exactly what this problem is calling for. It's calling for no duplicates, and so we can use a set here. And the basic idea is that you have a set with a value in it, and if you go ahead and add a value to the set, that's already in the set, nothing will happen, which is good. So what we can do actually is we want to take this string and we want to split it at the space, because each word is at a space. So this is all of the words, each word in the string, and we want to get each word, and then we want to stick this inside of a set. So by sticking this inside of a set, it's going to automatically get rid of each of our values. It's going to get rid of all of the duplicates. So duplicates are now gone. And now that we have this set, we want to turn it back into a string. So we want to do space, I don't know if I copied that, space dot join that value. So basically we're doing s.split at the space. We're getting a list of all the words. Then we're sticking that into a set. So if there are any duplicates, they will automatically go away. And then we're converting it from a set back into a string. So we're joining each thing in the set at this space. And so let's just see what happens here. It's giving us none, of course, because we have to return the value. But let's just see what happens here. So it's giving it to us in a random order, right? And that's because a set, the definition of a set is that it's unordered. And so, yeah, there's really no... It actually seems like this looks like it's in like reverse alphabetical order. I don't know, but by default, a set in Java doesn't have an order, and we don't want to do it in something like alphabetical order. We actually want to have it in the original order. And so I have an idea of something that we could try, but I'm sure there's a better way to do this. Let's just look up Python ordered set, and let's see if we can do something with that. Okay, so there is an ordered set. I think this is not built in, though. I think it's so this is someone else's code. So there is an ordered set, but we don't want to just copy code from another person. Then there's someone saying that you could do this like an ordered dictionary, which is interesting. So let's just see how they're doing it really quick. So they're calling... Okay, so basically what they're doing is they're using an ordered dictionary where the keys are all the values and all of the values are actually none. Because the idea is that a dictionary cannot have the same key point to two different values. The keys can't repeat. And that's the same sort of idea with a set. In a set, you can't repeat things, the keys of a dictionary also can't repeat. And so we don't care about the values in that case. All we really care about is the keys. So we could actually use an ordered dictionary. And in fact, I think in Python 3.6, dictionaries are ordered by default, although this is Python 3.4, so we would probably have to use the ordered dictionary. Let's just try. I have one idea that I want to try, and the idea is that we have this set, and we can turn this set back into a list because we basically want to sort this set of values. And you can't sort a set directly. You have to turn it back into a list, and then you can sort it. But the idea is that we want to sort each value based on where it first appears in the string. And so what we can do is we can say, like, words equals s.split at the space, and then we can just use words here. But the idea is that we can take this list here, and we want it to be sorted, but then we want to do lambda word. And we basically want to say, where is that word in the list of words? And so, let's see, Python list index of, let's see if we can do that. Looks like we have an index method, so that should work. So we can just do words.index word like that. And so basically we're sorting all of these values. Yikes, we do not want a virus. So we're sorting each of these words by where it first appears in there. And that is giving us an error. I wonder why. Let's see. It could be something to do with my parentheses. So it's saying a function object is not iterable. So words. So we're sorted, I think, I see why I did this wrong. So we need to sort it, and then afterwards we pass. Oh, these parentheses are pretty crazy. I think it's like key equals that. I think that's how you do it. Yeah, so it's the same. So this is like when you have that min and max, and you can specify a custom key for like a custom sort order. So basically I'm saying we want to sort these words, and by default it's going to sort them in alphabetical order, which is not what we want, but I'm going to sort it where the key is going to be, we take the word and we say, where is that word within our list of all of the words that we have? And this index is going to return the first index of that. And so the idea is that the words that appear earlier are going to have a smaller index, and therefore it's going to sort everything correctly. So instead of using the ordered dictionary approach, which I don't really want to do because it's going to take a little while, and obviously this is a better way to do it, we can just sort based on where that word appeared. Let's clean this up a little bit. We have this lambda function, but all this lambda function is doing is calling another function, so we can actually just pass words.index directly. So right, because a lambda function, so the lambda is just a callable function that takes one parameter and returns a number. Well, words.index is itself a function that takes one parameter and returns a number. So instead of wrapping it in a lambda function, we can just sort of use it directly like that. And so that will still work. I guess we didn't attempt, but there it passed 100 random tests. So clearly we are doing this correctly. But basically the idea is, once again, we're taking all the words in the sentence or in the list, we're converting them into a set to get rid of the duplicates, we're converting them back into a list so we can sort them, we're sorting them based on where they first appear in the string, and then we're taking it and we're putting it back into sort of like a sentence. And the last thing that we need to do to make this a one-liner is that the immediately invoked lambda function that I mentioned earlier, this might be a little bit more clear of an example because the example that I gave before was a little bit contrived. But the basic idea is that this is two different lines right now. And I'm going to explain this again briefly, just in case there are some people who didn't see. But this is two lines right now. I could make it one line with a semicolon, but it's still two different statements. And I really want this to be one statement. What I could do is I could replace words with s.split each time, and that's fine, I guess. But then the problem is that each time this happens, I have to call s.split. Like here, each time it evaluates the key function, it has to call s.split, which is less efficient. And plus, I'm repeating code, which I don't want to do either. What I can do, basically, I want to have this words variable still exist, but when you declare a variable, that's a statement on its own. But what I can do is I can wrap this entire thing in a lambda function like this. So now I have this variable called words defined. So I wrap this whole thing in a lambda function. This is in parentheses. And then after the lambda function, I call the lambda function immediately, and I pass it s.split space like that. And now this is a one-liner, right? So now this is a one-liner because it's one statement, but it still has this variable, and I basically had to sort of abuse the lambda function. So I created this function that has a parameter, so I can reference it multiple times, but then I call the function immediately with the value that it's supposed to have. And so, that's sort of a little trick that you can do, very common when you're trying to solve problems in one line, but you can see that it still works, and it was now done in a single statement. Now, if someone handed you this code to look at, and they just told you to try and figure out what it does, it would obviously be a lot trickier than if it were multiple lines. But I like these challenges where you start with your first attempt at it, and then you can gradually get it down into one line. So let's go ahead and submit this, and let's see what everyone else did. And then I think we're going to wrap up at that point because I've done quite a few challenges now. It's about an hour and 15 minutes into the stream, and so let's just see what happened. So here is someone using dict.fromKeys. So I wonder, let's just look this up. Python dict. I'm assuming that it uses all those values as keys, and then, well, let's just find out. It creates a new dictionary with the keys and the values, and they're just giving no value, so it would be null by default. So this is using sort of that ordered dictionary idea, where they're creating a dictionary from all of these keys, where the keys are this and the values are unknown because we don't care about the values. And then you're joining all of the keys back. So this is very similar to what we did, but it's just using an ordered dictionary, or a dictionary instead of a set. And I guess the dictionary is ordered in Python 3.4 then, but I don't know. I like that solution a lot. So here is an example. So they create a function called f, and then they call it there, so I don't know. But this is a generator function. So what they're doing is they're keeping track of all the words that they've seen so far, but then every time they find a new word, they're actually yielding it. So this is a generator. So basically what happens is it's going to look at that first word, and if they yield it, then it's going to give that first value back, but then it's going to keep going in the function until it finishes, and it's going to keep yielding words. It's going to keep handing words out as the function goes, and it creates what's called a generator. So that's actually a really cool way of going about it as well. It's obviously not a single line, but it's a cool way using a generator function, and that's why they had to wrap it in this function called f, is because it's a generator like that. This is the solution that we did. So I guess you can pass a set directly to sorted. I didn't realize that you could do that, so I wrapped it in a list, but I guess you can. So yeah, this is what we did. We just split it. I guess if you don't pass a parameter, it'll do a space by default, so that's also cool. And then the key is s.index, which is what we did. And so this is very similar to the solution that we had, just a little bit different. And then at this point, so there's ordered dict. So, there's the ordered dictionary approach. This is, this is just a regular old for loop if statement kind of thing. This is probably like a lot of people's first stab at it if you don't want to try and make it any fancier. I might have just clicked a button by accident. But that's basically it. So we wrote our solution. It was a pretty good solution. There's a couple of other really cool solutions as well. But I'm pretty happy with this problem. I think it's a cool problem. It's a great example of where you can use sets, but also of where sets aren't necessarily the best idea, or where you have to be careful of sets in the fact that they're unordered. And so at this point, we are about to hit 1 hour and 20 minutes, which is quite a bit. And so I'm going to sign off. I hope you guys enjoyed tuning in and watching some Codewars. I hope I was able to explain everything that I was doing well. I hope maybe you learned something, or maybe you'll actually try some of these problems on Codewars on your own. If you guys enjoyed this video, those watching live and those watching the recording of the stream, let me know, because I would be more than happy to do more videos like this where I just, live stream and write some code, maybe answer some questions, like whatever is cool. So yeah, I'm gonna sign off now. Thanks for tuning in, guys. Thanks for watching, and I'll see you guys soon with some more coding. Bye for now.